All right, we're back. Go figure 1.4. We're still in the textbook Brown, Theodore et al. Chemistry, the Central Science. So we're given this nice figure. We're prompted with the question, in which form of water are the water molecules farthest apart? I'm going to zoom in a bit here. Just look at this a touch closer. Again, in which form of water are the water molecules farthest apart? It's an interesting look, sort of, at the molecular level here. We see the water molecules, the red spheres are the oxygen atoms, the white spheres are the hydrogen atoms. We've got three different categories, pretty obvious to tell. They make note of water vapor here, and a little picture. Then what does liquid water look like at the molecular level? And then what does ice look like at the molecular level? Pretty interesting substance, water. Something we interact with so regularly in three different forms. Here's an application they give. The three physical states of water: water vapor, water liquid or liquid water, and ice or solid water. We see the liquid and solid states, but we cannot see the gaseous or the vapor state. When we look at steam or clouds, we see tiny droplets of liquid water dispersed in the atmosphere. The red arrows show that the three states of matter interconvert. So you can notice this farthest red arrow that I'm tracing here. We've got interconversion between the iceberg, solid ice, and the atmosphere. So the exchange of water going from solid to gaseous, and then reverse gaseous to solid, sublimation, deposition. Then we have this middle interconversion arrow, liquid water to water vapor between the frigid ocean there. And then this farthest right interconversion arrow where we see liquid water and solid water interconverting. So we've got freezing, melting, and from the liquid to the gas, evaporation, condensation, and then sublimation, deposition. So an interesting example of how they all three interconvert. But to wrap up the question, we're looking for where water molecules have the most space between other water molecules, and here, with pressure, temperature being equal between the three states, we can readily tell that water vapor spaces the water molecules apart the most. Good thinking strategy, especially for an undergraduate chemistry course. Ask yourself the opposite question: in which form of water are the water molecules closest together? And if you had that question, we can see that it looks like liquid water based on the picture. And if we were looking for where the water molecules have the most order or structure, we would say ice.